Okay, so this tutorial is going to demonstrate how to make a twin stick shooter. Some early incarnations of this type of game were games like Smash TV and Robotron. The two really main defining characteristics is that it's a top-down view and that the control of movement and that the control of direction firing are separate, hence named twin stick. So on a modern um, dual controller, you could use the left analog stick to move the character around and the right analog stick to control what direction they're firing. So they could be moving horizontally to the left but shooting diagonally up to the right in combinations like that. So you could also use this for like a 3D crawl. Although some of those games tend to make you face in the same direction that you're firing or move in the same direction that you're firing. So what we're going to do is this will be a few videos, and we can build on it if there's anything that you want. This is really a game that could be done either in the 2D or 3D environment. I'm going to demonstrate it in the 3D environment because you could easily replace the 2D sprites with 3D polygons, models, and then you could just by altering the camera, you could then have yourself like an isometric view. So like you could turn the twin stick shooter into like a 3D dungeon crawl. Anyways, so we'll take it one step at a time. These images were simply dragged and dropped from an external folder, so getting them into a project is easy. Now, if you want something to be a texture, like here's the floor tiles that's going to be used on, obviously, the floor. When you bring in an image in, by default, it's a texture, so that's fine. But if you want something to be animated, like, say, a player character or something like that, and you don't want it to be a texture, that's going to be a sprite, like these, you need to change it to texture. So just change it to sprite from texture. You can uncheck that, and then you just change it to whatever size is bigger than the size of the image without going below the size of the image. It helps with compression. So we'll just apply, and you can see how they change. Those are now being treated like sprites, not like textures. So all these we want to be sprites except this one. This one we do indeed want to be a texture. So let's get right into it. So game object, 3D object, plane. Let's take that tile. We're going to drag and drop it. And what's going to happen is a folder called materials is going to spontaneously be created with a floor tile material in it. See how the folder appeared? It automatically creates a texture for you when you, a material for you. It automatically creates a material for you if you drag and drop a texture onto an object. Now, if you click on this, anywhere that material appears will automatically be changed. So let's go ahead and increase the tiling. Let's make this like 9 by 9. Now, even though we're in the 3D environment, we're going to ignore gravity. There's two ways you could go about this. You can either take the camera, rotate it down, or you can just rotate everything towards the camera. Since the images are drawn as if the camera is facing down on them, it's a wash either way how you want to do it. So we'll just take the floor and we'll rotate it up. Now if you notice, you can't see this side. That's because it's a 2D plane. So even though it calls it a 3D object, it's kind of like a mirror or a window on in an interrogation room in a police station. You see a mirror on one side, but the other side is a see-through window. Very similar. One side has the texture, the other side is transparent. So we'll just rotate this perpendicular, so that's a -90. We'll click on the main camera. So there's our floor. So now we just need to move the floor around a bit, and we can expand it. Now keep in mind, if you make an object bigger, you may have to alter how many times the image is tiled that is on it, because it'll stretch them. So let's just make this twice and twice. So X scale and Y scale, X scale and Z scale. It doesn't have a Y scale. That would be depth. and it doesn't have that. So let's go ahead and view that. All right, so now we can just move it a little bit closer to the camera and move on. So it's kind of like you're in a haunted house because you're staring at this floor. And let's go ahead and run it. So, even though you're in a 3D environment, it really doesn't look that much different than a 2D environment. Maybe you got a little bit of lighting on it, but you could do that with the 2D environment as well. Okay, so now what we're going to do is we're going to add the playable character. So we're just going to take our little Shinigami here, drag her, drop her into the hierarchy, and let's take a look. So actually we need to put her in front of the plane. So if the plane is at, might as well make that -1. There we go. Then we'll put her at just above -1. Again, even though it's a 3D environment, we're not really using that Z-axis all that much. So, okay, that looks fine. Now, what we're going to do is we're going to start adding some control to her. A couple of things that need to be done. She needs to have a rigid body physics object. So physics, rigid body, get rid of gravity. We won't be using it. And for constraints, we really don't want her rotating if there's a collision, but we do need to be able to rotate her with the controller. So we may have to freeze the rotations eventually. We'll see how it works out. But I just want to let you know that you can do that. Now, the reason why that needs a rigid body is because when you're moving a character around, you're actually applying velocity. So you give them the momentum in a certain direction. So let's go ahead and create our first script. Write, create, C#, and we'll call this hero control. Click on the Shinigami, click on hero control, or should I say drag and drop it. And now if you double click that, that'll get you into whatever text editor you're using. I'm using MonoDevelop. You can change in the preferences because I guess in some versions, what will happen is instead of MonoDevelop, Visual Studio will open up, and Visual Studio requires a separate license. So you can go into preferences and say, okay, I don't want Visual Studio, I want MonoDevelop. Now, let's start. Okay. I could just start putting the code in here, but I want to point out something first. So if you have the controller, joystick, gamepad, whatever, plugged in, and you start up Unity, if you go to Edit, and you go to Project Settings, and you go to Input, this is what you should see. Depending on how many things you have plugged in, this number is going to be bigger. So in this case, we're looking at number 18. Horizontal is just that, a horizontal axis. And I want to pause here for a second. Unity doesn't really think of a controller as a left analog stick and a right analog stick. It sees a vertical axis, it sees a horizontal axis, it sees another vertical axis, and it sees another horizontal axis. So if you're looking for coding that says like analog 1 or analog 2, you're not going to find it. You actually have to code for the separate axes. So horizontal, so that one's there by default. But we have to make some changes. So first of all, we want to give a little bit more of a dead zone. We don't want this to be too sensitive because when you're moving the controller, what you're really doing is you're creating a number that ranges 0 to -1 or 0 to +1, and it goes out to like 8 decimals. So that's a little bit too sensitive. Maybe you want it to be that sensitive, maybe you don't. I know that like in some fighting games, I've barely tapped the controller and something happens, so to me, that's too sensitive. Invert changes which way is negative, which one is positive. Type, it defaults to key or mouse, so we want to change this to joystick axes. The axis with the x-axis because it's horizontal. Joy number, we'll use joystick 1. Now, if you want to have not greater control, but in the code, you may want to remind yourself, okay, is this code looking for horizontal movement or horizontal shooting? So you might want to actually change this. So let's call this X move. Now we'll go to vertical. We'll rename that Y move. Again, we'll reduce the sensitivity. And we'll again change this to joystick axis. This time it's going to be the Y axis, and it's going to be joystick 1. So far, so good. So you've configured the left analog stick. Now for the right. So come down here to the additional horizontal, and we'll call this X shoot, because we want to remind ourselves that we're shooting horizontally. And you can see by default it bumps up the sensitivity a bunch, but for consistency's sake, we'll bring that back down. Sensitivity would be, this is the dead zone. So dead zone is really threshold. Think of this is the minimum amount that it has to be pressed in order to trigger. Okay, so there's a minimum threshold. So I talked about sensitivity, but sensitivity as a setting is actually slightly different. So it gives you the description right there if you point at it. Speed to move towards target, value for digital devices. So in other words, you can actually change the sensitivity as well. So this is the dead zone is really the threshold. How much is the minimum you have to press before it registers a reading or stops registering a reading? We won't mess with sensitivity though. We're not worried that much about it. So by default, this one is joystick axis, X-axis, and again we want to go to joystick 1. Actually, we don't want X-axis, sorry. We want third axis. And then for vertical, we'll call this Y shoot. And again, dead zone threshold of 0.01. And this will be joystick axis. This will be fourth axis. And this will be joystick 1. Now, we might have to double check something because my controller, I think the third axis is actually the triggers. So actually, let's make this one fourth axis and this one fifth. I believe that's what it has to be. So the axis has a very specific meaning to the device and to Unity. So I believe that's what we want. We can find out really quickly. Okay, so we've configured it. Now we're going to actually use those names to say what we're looking for. So in the update section, we're going to capture those into variables. That way it's not so messy to look at. So public, float, since it's a decimal, we'll call this X val, and we'll call it ADJ, because rather than doing a yes or no, we're going to allow for a range of speeds. So, and public float y val ADJ public. So that's for moving. Float and this is more of a yes or a no, because you're really not changing the speed in which you're shooting. So let's just call this, we don't want to use the same words as X shoot and Y shoot, which we used in the input section. So let's call it X fire and Y fire. Now what you can do is you set those values with every frame, because the update section gets run once per frame. So we want to keep updating those values with whatever you're doing on the analog stick. So xval adjust equals, and here we go. This is what actually grabs the value. So input, because you're looking for play input, dot get axis, and then it's the name of the axis. So X move, and it is case sensitive to the best of my knowledge. So what you're saying is take that value, because again, it's not yes or no, it's analog. So it's a range of numbers. Technically from 1 all the way to -1, but if it's at rest, it's 0. Yval equals input get axis, and that was Y move. And so let's just do moving for the moment, is we're going to handle shooting a little bit different. So with every frame, so get component. Now the reason why it's called get component is when you click on an object, it has components. Like we added a rigid body component, we added a script component. Well, get component does just that. It grabs one of those components and allows you to make a change. So what change? Well, we're going to make a change to rigid body. And what attribute are we changing? We're changing velocity. We want the X velocity to change based on the horizontal, so the X move value. And this is why it's an adjustment, because it's not just moving the speed, because the number of ranges, like I said, 0 to 1, 0 to -1. Well, one velocity is really slow. So you want to multiply that velocity by another number. So let's take 3 times xval. So now it makes a little bit more sense that it's a velocity adjustment. And 3 times yval, and we don't use z. So, oops, sorry, my apologies, this is a vector 3, so new vector 3. So get component rigid body velocity, new vector 3, there's the x vector, there's the y vector, and there's the z vector. So if I haven't made any mistakes, this should already be enough to move the character around. Now they won't rotate because it's not looking at rotation, that's a separate command. But they should move around. So I'm going to press up. Alright, so down. Alright, so that needs to be inverted. Left, right. So left and right is fine, but up and down needs to be inverted. And they're kind of sliding around a little bit. So that might be my controller. Or we can, like I said, tweak that dead zone. So let's go back to edit. And we can go back to project settings and input. And remember what I said about invert? We could invert. So that was the vertical, I believe, that I said wasn't working. So we can just invert that. So now, see, up is now up, down is now down. See, it's kind of sliding there. X is X, Y is Y. So a couple of things we can do. Oh, and one more thing. If you move it just a little bit, so if you move it just a little bit, see how they're moving slowly and then faster? So I move it up slowly, faster. So it's not that obvious, but see, you can definitely see slower there and faster now. So 3 actually might be a little bit too slow because you don't have enough range. But again, that's a game balance issue, so I'm not going to mess around with it any more than that. You now see how to do it. That's really just a game balance issue. And I think that's probably enough for one video. I'm thinking that we're going to bring that dead zone up a little bit more. Let's move that to 1 because, like I said, they're kind of sliding around a little bit even when the controller is neutral. So let's move that up to 1, and we'll run it one last time. So it takes a little bit more before they start to move. Yeah, they're not sliding around now. That looks like that took care of it. So a lot of little tweaks to get the gameplay that you want. So like I said, you can move them slower, faster, even faster. And you can have a greater range of speeds as well because, as I said, this is a completely arbitrary multiplier that I took. You can make it 4, 5, 6, however fast you want your character to be. All right, so that should do it for this first video.